In this video we are going to study an Android app called BouncingBall. This app uses a thing called thread to time animation. The app is quite simple, so that there is a ball bouncing on the screen and the ball is moving. But to make this happen we need to update the screen something like 25 times per second. So let's start and let's make this app scene here. So if you want to get this app for yourself, you have to go to naturalprogramming.com, and through the Android icon you will find this page, and then there's a link to simple Android applications, and there is a single Java file, BouncingBall activity.java. And I will now show that how we can take this app into use. So I will make a project in Android Studio, a new project, and it's empty activity, and well, the name of the app might be Bouncing Ball, and the package name must be bouncing.ball, and well, the location is okay and language is okay and the API is okay, so I say finish. And now the studio starts creating the project. It takes a few minutes, I think, or few seconds at least. And let's go to this file then, and we can start doing something. So we can just download this file by right-clicking and saying save file as, and then we have to select our project, and there is this Bouncing Ball project, and there are these many subfolders, and I will just copy the file there like that. Now the file is copied, and in the studio I have to do one trick. I have to modify this Android manifest and change the name of the main activity, and now it's going to be Bouncing Ball activity. This should work. Let's try it. Yes, it works now. So now our app is running there. So the ball is bouncing and it is also rotating, and there is one feature there that when the ball is touched with a finger or with a mouse in the emulator, it kind of explodes like that. And if I retouch the screen, the ball emerges again and continues bouncing there. So that is how this app works. So let's go then, and I will open this file to another editor so that it's easier for you to see it. Again, there are these folders. I will open it with the Sublime text like this. So it is only this single file, and this this program doesn't need any XML files. So let's take first a look at the end of this file. So it is quite a long file, many Java classes there. So we have this, our activity class is there, so that it is derived from the standard activity, and we have the onCreate method there, and we create a new object of this bouncing ball view, and then we set that as content of this view. And then we also have this onStart and onStop methods, and there we call these methods to start the thread and stop the thread. But all the rest of the functionality of this app is then built into the bouncing ball view class, and of course that's exploiting the other classes at the beginning of this file. But let's first take a look at this one. So we have this bouncing ball view that is a subclass of standard view, and it also implements this interface named runnable. And this is now an important thing when we are using these threads, and it means in practice that we must have in this file we have a method named run, and we have also this object reference that will be pointing to the thread, and we have this boolean variable to control the execution of the thread. And also we create the bouncing ball, and that will be pointed by this object reference. Okay, and then on size changed, this is called when the view is visible, and we record the width of the view and the height of the view, and we specify a bouncing area for the ball. And so then we create a ball that is an object of class exploding bouncer like this, and then we specify here that the initial position of the ball is this point F object, and the initial color is green, and then we also supply the bouncing area for the ball, and the bouncing area is defined so that this is the coordinates of the upper left corner, and it occupies the entire screen. And then we have these methods: start animation thread and stop animation thread, and these are called from the activity class. And when we start, we have to check that if the thread doesn't exist, then we create it like this, and we set this variable to value true, and when we call the start method. And what this means in practice, it means that the system starts executing in parallel with this actual application. It starts executing this run method here. And then there is this stop animation thread, and this method just stops the animation when it is no longer needed. But this run method is then the essential thing here. So that is the method that runs parallel with this other application, and there is this boolean variable that is controlling the execution of this run method, so that it is executed almost forever as long as this variable has value true. And what we are doing here, it is that we just check that if the ball on screen, if it is something else than null, so that it has been created, then we move the ball. And then we call this method post invalidate, which means that the screen will be updated. We must, when we are using a thread, we must use this post invalidate in place of the normal invalidate method. And then we are using a method like thread sleep. And for this sleep method, which is a static method of class thread, we specify the number of milliseconds that this thread should sleep. And when we specify this 40 milliseconds, it means in practice that this thread sleeps so that it is executed, so that this thing is executed something like 25 times each second. And this thread sleep method must be called inside a try catch construct. But what this basically does, it is that it moves the ball and asks the screen to be updated, and then it sleeps, and then it again moves the ball, asks the screen to be updated, and then it sleeps. And it does this something like 25 times each second. Then here we have this Untouched event, when the screen is touched, so that we can check things like that. If the ball on screen, if it is exploded, then we specify again bouncing area, the whole screen, and then we again create this exploding bouncer, and we specify the initial point and the color and the bouncing area. So we remake this bouncing ball. But if it is not exploded, then we check that if this point that is touched, if it is in the area of the ball, then we explode it. So here, when we run this, if I click it, then we explode it. And then if it has been exploded, it is already exploded, then if I click the screen, the ball is recreated. And also this explode ball is such that this method just initiates the explosion, but the ball class is, or the exploding bouncer class is so clever that it can explode the ball automatically. So we don't have to in this class we don't have to worry about how the explosion takes place. And then there is this onDraw method, and there is only the ball thing there, and we just call the draw method for this ball object, or the exploding bouncer object. So that is the class BouncingBall view. And then there are quite many other classes here. Let's take a look at this. So there is a kind of class hierarchy, and there is the graphical object class, and this object has a center point, and it has a velocity, and it has color. So this could be a class. So this is the base class for these ball classes, but of course this could be a base class for other graphical things. And there are things like set color, get object position, move right, move left, and so on. Not all these are used in this program. So then we have this class called bouncer, and now that is a subclass of graphical object. And now this bouncer has certain new data fields like bouncer radius, bouncer direction, and this bouncing area. And this bouncer direction is calculated so that it is a random direction at the beginning. And this radius is also fixed, but then when we create a bouncer, we give it the initial position, a color, and the bouncing area. And these are just copied to these data fields. And there are methods like that you can shrink the bouncer and you can enlarge it, and you can set the radius. And then there is this method contains point, so that you can check, or we are using this, that if this given point is inside the area of the ball. And we are using the famous Pythagorean theorem to calculate this distance between this point and the center point of the ball. But then there is this move method. And this is now somewhat interesting, as it is now called something like, in this program it is called something like 25 times each second. And what this simply does, it takes the current object center point and it uses these functions like cosine and sin to calculate a new position for this ball. And with this set operation, it sets then this the new position. So it uses the velocity and the bouncer direction to calculate a new center point for this ball object, and then after it has calculated the new center point, it just starts checking that if the ball or the bouncer, if it hits some of the walls of the bouncing area. And here are these checkings that, for instance, if the y-coordinate minus the bouncer radius is less than the top edge of the bouncing area, then it has hit the northern wall, and then with this kind of statement it's possible to change the direction so that the bouncing continues quite nicely. So there is an if statement that studies all these possible walls that can be reached. And then there is the draw method, and this is also called something like 25 times each second. And well, we are just drawing a circle with the filling paint, and we are drawing a circle with outline paint, and always we are using this object center point X and object center point Y and the boundary radius when we are doing the drawing. But this basic bouncer, it can only bounce, but it cannot rotate, or it cannot explode. So for that reason we have two other classes here. So there is this class rotating bouncer that is now a subclass of this other class, and now this has some other data fields like current rotation and another ballpoint, because now you can see that there are some areas with different color there, so that it's possible to notice the rotation. And we just set that there is another color, so otherwise we just pass these parameters to the superclass, and then we set another ball paint, and we set the color to dark green. And then there is the move method that is overridden here, and we first call the superclass method, and then we check the rotation, that if the rotation, we add some degrees to the rotation, and if the rotation is more than 360, then we set it back to 0. And this rotation is used then when the rotating bouncer is drawn to the screen. So here is the draw method for this class, and again we call first the superclass method, and then we save the state of the canvas, and then we translate the coordinates, and we rotate the coordinate system according to the current location, and we use these draw arc methods to draw these dark green areas to the ball, because otherwise it would be just bright green. But with these two calls we draw the dark green areas over there, some parts of the ball. In the end we restore the original coordinate system. And then the final class here in this class hierarchy is the exploding bouncer, and that is now the subclass of the rotating bouncer. And we are using some static variables here to describe this ball state. So the ball can have 3 different states if it exists, so that it can be alive and well and bouncing, and it can be exploding, and it can be exploded. And the explosion is made so that, if we can take a look at here, that if I click it, you can see that the ball stops moving and it is gradually filled with the yellow color. So it stops moving and it's gradually filled with a yellow color. So that is kind of explosion then, and we just create this ball or the exploding bouncer with a normal parameters or parameters for this constructor, and we pass them to the superclass. But there are these certain methods like explode ball and ball is exploded. So when this is called, we set the ball state to exploding, and we enlarge a little bit. So, and when this state variable has this value, the other methods know that they must be behaving in different way. And well, with this we can then study that if the ball is already exploded. So the move method works now so that if the ball is alive and well, then we just move it as usual. But if it is exploding or exploded, then we don't move it at all. So for that reason, when we explode the ball, it stops. And then there is this draw method. And again we check the state of the ball. So if it is alive and well, we just call the superclass method. But then if it is exploding, so we check, we are doing so that there is this explosion color alpha value. So this alpha value tells that how much a color is transparent, and when it is 0, it's fully transparent. So this value is 0 at the beginning, so it is fully transparent at the beginning of the explosion process, but then here we gradually increase this value, and in the end it reaches so big value that it is more than this FF, and so then we set the state to ball exploded. But then here it is in this area of the code it is still exploding. So we first draw the ball normally, but then we create this explosion paint, and we set the color to yellow, and we use the current alpha value. And then we just draw a circle around in the same over the ball with the yellow color. And so when we decrease the transparency, in the end it will be completely yellow. So it works like this. So this is a kind of simple way to make an explosion. Yes. So I think this is about all of this. This program, so that it's important to understand here that this ball knows where it is located, how it is moving, how it is handling collisions, and how it knows how to explode itself. And with methods like these, we can then say that now it's time for it to explode, or here we say that you have to explode yourself, and with this method we can then check that if it has exploded already. Okay, I think this is all about this program. So thank you for watching this video, and maybe we will meet in some other video then. Thank you and bye bye.